It is important to understand the concept of the fundamental AWS database services that are available to you. These services include Amazon RDS, the relational database service, DB instances, security groups, RDS interfaces, Amazon DynamoDB, DynamoDB data models, supported operations for throughput and accessing DynamoDB. An SQL database stores data in rows and columns. Rows contain all the information about one entry, and columns are the attributes that separate the data points. An SQL database schema is fixed. Columns must be locked before data entry. Schemas can be amended if the database is altered entirely and taken offline. Data in SQL databases is queried using SQL, the structured query language, which can allow for complex queries. SQL databases scale vertically by increasing hardware power. NoSQL databases store data using one of many storage models, including key-value pairs, documents, and graphs. NoSQL schemas are dynamic, and information can be added rapidly. Each row doesn't have to contain data for each column. Data in NoSQL databases is queried by focusing on collections of documents. NoSQL databases scale horizontally by increasing servers. No one size fits all when considering database types. You must take into consideration your data requirements, such as data formats, data size, the frequency of your queries, how quickly you need your data, and for how long you need to keep it. These are the services AWS provides: Amazon DynamoDB, Amazon Elasticache, Amazon RDS, Amazon Redshift, and AWS Database Migration Service. With Amazon RDS, you can access the full capabilities of a familiar MySQL, MariaDB, Microsoft SQL Server, Oracle, or Postgres database. In addition, Amazon RDS for MySQL provides two distinct but complementary replication features: multi-AZ deployments and read replicas that can be used in conjunction with each other to gain enhanced database availability. You can protect your latest database updates against unplanned outages, and you can scale beyond the capacity constraints of a single DB instance for read-heavy database workloads. Amazon Aurora is a MySQL-compatible relational database engine that is part of Amazon RDS. Amazon RDS is a web service that makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while managing time-consuming database administration tasks. This in turn allows you to focus on your applications and your business. Amazon RDS gives you access to the full capabilities of a MySQL, Oracle, SQL Server, or Amazon Aurora database engine. This means that the code, application, and tools you already use today in your existing databases can be used with Amazon RDS. Amazon RDS is a web service that makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while managing time-consuming database administration tasks. This, in turn, allows you to focus on your applications and business. Amazon RDS gives you full access to the capabilities of a MySQL, Oracle, SQL Server, or Amazon Aurora database engine. This means that the code, applications, and tools you already use today with your existing databases can be used with Amazon RDS. Amazon RDS automatically patches the database software and backs up your database, storing backups for a user-defined retention period and enabling point-in-time recovery. You benefit from the flexibility of being able to scale the compute resources or storage capacity associated with your relational database instance via a single API call. The basic building block of Amazon RDS is the DB instance. A DB instance is an isolated database environment in the cloud. A DB instance can contain multiple user-created databases, and you can access it by using the same tools and applications that you use with a standalone database instance. You create and modify a DB instance by using the AWS Management Console, the AWS Command Line Interface, or the Amazon RDS API. When automated backups are turned on for your DB instance, Amazon RDS automatically performs a full daily snapshot of your data during your preferred backup window and captures transaction logs as updates to your DB instance are made. When you initiate a point-in-time recovery, transaction logs are applied to the most appropriate daily backup in order to restore your DB instance to the specific time you requested. Amazon RDS retains backups of a DB instance for a limited, user-specified period of time called the retention period, which by default is 1 day, but can be set up to 35 days. Manual database snapshots are user-initiated and enable you to back up your DB instance in a known state as frequently as you want, and then restore to that specific state at any time. DB snapshots can be created with the AWS Management Console or Create DBS Snapshot API, and are kept until you explicitly delete them with the console or Delete DBS Snapshot API. Manual database snapshots are kept in Amazon Simple Storage Service, Amazon S3. There is no additional charge for backup storage up to 100% of your consumed database storage for an active DB instance. Cross-region snapshot copy is available for all Amazon RDS engines. You can copy snapshots of any size. Sizes can be moved between any of the public AWS regions, and you can copy the same snapshot to multiple regions simultaneously by initiating more than one transfer. There is no charge for the copy operation itself. You pay only for the data transfer out of the source region and the data storage in the destination region. You can manage access to your Amazon Relational Database Service resources and your databases on a DB instance. The method you use to manage access depends on what type of task the user needs to perform with Amazon RDS. You can manage access to your Amazon Relational Database Service resources and your databases on a DB instance. The method you use to manage access depends on what type of task the user needs to perform within Amazon RDS. Run your DB instance in an Amazon VPC for the greatest possible network access control. Use AWS Identity and Access Management (IAM) policies to assign permissions that determine who is allowed to manage RDS resources. For example, you can use AWS IAM to determine who is allowed to create, describe, modify, and delete DB instances, tag resources, or modify DB security groups. Use security groups to control which IP addresses or EC2 instances can connect to your databases on a DB instance. When you first create a DB instance, a firewall prevents any database access except through rules specified by an associated security group. Use secure socket layer SSL connections with DB instances running MySQL, MariaDB, Postgres, or Microsoft SQL Server database engines. Use Amazon RDS encryption to secure your RDS DB instances and snapshot at rest. Amazon RDS encryption uses the industry standard AES 256 encryption algorithm to encrypt your data on the server that hosts your RDS DB instance. Use network encryption and transparent data encryption with Oracle DB instances. Use the security feature of your DB engine to control who can log into the databases on a DB instance. This slide shows a simple application stack with an application running in an Amazon EC2 instance supported by a master database running in an Amazon RDS database instance. Presenting the application behind the ELB, Elastic Load Balancer, allows for compute resiliency and scaling features such as auto-scaling and ELB groups to be adopted in the future. Amazon RDS multi-AZ deployments provide enhanced availability and durability for database instances. This makes them a natural fit for production database workloads. When you provision a multi-AZ DB instance, Amazon RDS automatically creates a primary DB instance and synchronously replicates the data to a standby instance in a different AZ. Each AZ runs on its own physically distinct, independent infrastructure and is engineered to be highly reliable. In case of infrastructure failure, for example, instance hardware failure, storage failure, or network disruption, Amazon RDS performs an automatic failover to the standby so that you can resume database operations as soon as the failover is complete. Because the endpoint for your DB instance remains the same after a failover, your application can resume database operation without the need for manual administrative intervention. This slide shows an application stack that uses AWS reliability and durability features. An Elastic Load Balancer group of Amazon EC2 instances supports the application logic. The instances use a multi-AZ Amazon RDS deployment. In the event of infrastructure failure, the database fails over to the standby instance. The application logic retries its database connections to the same endpoint as before, and the service resumes using a new master. Meanwhile, a new standby is instantiated. In addition to the Amazon RDS automatic backup feature, the database snapshot feature is used to ensure that the backups are durably retained. You can create a new database instance from the database snapshot whenever you want. Monitor your memory, CPU, and storage usage. Amazon CloudWatch can be set up to notify you when your usage patterns change or when you approach the capacity of your deployment so that you can maintain system performance and availability. Use multi-AZ deployments to automatically provision and maintain a synchronous standby replica in a different availability zone. Enable automatic backups and set the backup window to occur during the daily low in write IOPS. On a MySQL DB instance, do not create more than 10,000 tables using provisioned IOPS or 1,000 tables using standard storage. Large numbers of tables will significantly increase database recovery time after a failover or a database crash. If you need to create more tables than recommended, set the inodb file parameter to 0. Avoid tables in your database growing too large. Underlying file system constraints restrict the maximum size of a MySQL table to 2 terabytes. Instead, partition your large tables so that their file sizes are well under the 2 terabyte limit. This approach can also improve performance and recovery time. If your client application is caching DNS data of your DB instances, set a TTL, time to live, of less than 30 seconds. The underlying IP address of a DB instance can change after a failover. Caching the DNS data for an extended time can lead to connection failures if your application tries to connect to an IP address that is no longer in service. Test failover for your DB instance to understand how long the process takes for your use case and to ensure that the application that accesses your DB instance can automatically connect to the new DB instance after failover. Amazon DynamoDB is a fully managed NoSQL database service that offers high performance, predictable throughput, and low cost. It is easy to set up, operate, and scale. With Amazon DynamoDB, you can start small, specify the throughput and storage you need, and easily scale your capacity requirements in seconds as needed. It automatically partitions data over multiple servers to meet your requested capacity. In addition, Amazon DynamoDB automatically replicates your data synchronously across multiple availability zones within an AWS region to ensure high availability and durability. In Amazon DynamoDB, a table is a collection of items, and each item is a collection of attributes. Each attribute is an item in a name-value pair. An attribute can be scalar, single-valued. It can be a JSON document or a set. When you create a table, in addition to the table name, you must specify the primary key of the table. As in other databases, a primary key in DynamoDB uniquely identifies each item in the table so that no two items can have the same key. When you add, update, or delete an item in a table, you must specify the primary key attribute for that item. DynamoDB supports 2 different kinds of primary keys. A partition key, a simple primary key composed of one attribute known as the partition key. DynamoDB uses the partition key's value as input to an internal hash function. The output from the hash function determines the partition to which the item is stored. No two items in a table can have the same partition key value. Partition key and sort key. A composite primary key composed of 2 attributes. The first attribute is the partition key, and the second attribute is the sort key. DynamoDB uses the partition key value as an input to the internal hash function. The output from the hash function determines the partition where the item is stored. All the items with the same partition key are stored together in sorted order by sort key value. It is impossible for 2 keys to have the same partition key value, but those 2 items must have different sort key values. When you create or update a table, you specify how much provision throughput capacity you need for reads and writes. Amazon DynamoDB will allocate the necessary machine resources to meet your throughput needs while ensuring consistent, low-latency performance. A unit of read capacity represents one strongly consistent read per second or two eventually consistent reads per second for items as large as 4 kilobytes. A unit of write capacity represents one write per second for items as large as 1 kilobyte. The query operation enables you to query a table using the partition key and an optional sort key filter. If the table has a secondary index, you can also query the index using its key. You can query only tables that have a composite primary key. You can also query any secondary index on such tables. Query is the most efficient way to retrieve items from a table or a secondary index. Amazon DynamoDB also supports a scan operation, which you can use on a table or a secondary index. The scan operation reads every item in the table or secondary index. For large tables and secondary indexes, a scan can consume a large amount of resources. For this reason, we recommend that you design your application so that you can use the query operation mostly and scan only when appropriate. You can use conditional expressions in both the query and scan operations to control which items are returned. This slide shows a simple application architecture using Amazon DynamoDB to store data processed by applications on an Amazon EC2 instance. One type does not fit all. The choice depends on several factors. You can use both relational and NoSQL databases in one application depending on your requirements. This table provides a side-by-side comparison of relational and non-relational databases. Amazon provides several database alternatives for developers. You can run fully managed relational and NoSQL services, or you can operate your own database in the cloud on Amazon EC2 and Amazon EBS. If you need a relational database service with minimal administration, consider using Amazon RDS. If you need a fast, highly scalable NoSQL database service, consider using Amazon DynamoDB. If you need a relational database you can manage on your own, consider using your choice of relational AMIs.